Good afternoon. Today we are in the lecture 11 of unit 1. The topic is differential manometers, their derivation and problems. In the last class we have discussed about piezometer, U2 single manometer and their associated problems. So in this class I will discuss the topic differential manometer. In that you are having U2 manometer, inverted U2 manometer, micro manometer and their problems. Now we'll go the manometer concept step by step. So what is the main reason of this using of manometers means to study the pressure of a fluid in a closed or open container. To study the pressure of a fluid at any point in a closed or open container. Okay, right. So if you see a single column micromanometer, so it is simply a type of manometer where similar to as U2 manometer, what we are discussing in the last class, only the difference is a small reservoir is kept at this position. So mundu manam cheppina U2 manometer lo you don't have this type of reservoir. So directly you are having just a line like this. So it is connected to one pipe, right? Okay, na? Now, but here you are having a small difference, that is you are having a small reservoir or a chamber where shown in this figure. Now, a micromanometer has a glass tube bent in the U shape. So this is a glass tube which is bent in a U shape and inclined and has a small reservoir in the tube. So you are having a small reservoir in the tube. So U shape అనేది straight గా ఉండొచ్చు లేదంటే you are having a bend. I'll show you in the next slides. U shape has a small reservoir in the tube having some amount of same or other type of fluid. So problems lo kuda if you see this circular is a closed container. So just a pipe anukunnam. This is a circular it is a pipe. So it is a pipe where you are having some water here, where you are having a water in this pipe. So whereas in the manometer you are having another fluid or on the same fluid. So if you are taking another fluid, the fluid may be mercury or any kerosene or any oil. Whereas here you are using the water as a medium. If you see whenever the liquid is in the container, whenever the other manometer fluid is in this glass tube, it is open to the atmospheric pressure at a level of datum line XX. Now here A is nothing but area of a fluid at certain point. PA is a pressure of a point in the fluid. Okay, na? Now if you see whenever the fluid is going into this chamber, automatically the manometric fluid what is there in here okay. Sorry for the technical problem. You're having some technical problem from my side. Okay, we'll continue. So here, whenever you are seeing the change, whenever you are seeing the change in the head's height of the liquid, then automatically the manometric fluid is moving to certain height from the XX line. So with that x-axis line, we can conclude that the manometer is moving certain height as shown in this figure. Then whenever it is moving certain height, you can see the height difference. Here if it is initially h, it is the changing in the datum line, it is h1 and h2. Thereby automatically the atmospheric pressure is inside the manometer. But here you are having the pressure inside the fluid only, right? Next. Now if A is less than A, what is A here? Here A is the area which is present inside the tube. The atmospheric air from here to here. This is nothing but the area, small a, and this is nothing but the big A, capital A, where the fluid area is located. Right? Next one. Okay. Sorry for the technical problem. Now, if you see what are the changes happening at this point. So if A is less than A, then A by A is equal to 0. A by A is equals to 0, where it gives the formula H is equals to H2 S2 minus H1 S1. H2 S2 minus H1 S1. Then if the tube is inclined position in the previous figure, you have seen the U-tube is in U shape. The U-tube is in the U shape, whereas here the U-tube is in the slant shape. The U-tube is in the slant shape. So whenever the U-tube is in the slant shape, automatically the changes takes place then with the length as well as the angle of the tube with respect to the ground. Then whereas alpha is the angle of a reservoir at any point, then H2 is equals to L2 alpha. H2 is equals to L into sine alpha. Thereby H is equals to A by A, L into sine alpha, S2 minus S1, difference in the specific weight, plus S sine alpha S2 minus H1 S1. So just here you are substituting, then here H2 you are substituting at this point. H2 value is you are placing at this point, and remaining balance is H1 and S1. This one is added more extra. Why? Because you are having an angle theta. Now the voice is okay. Hello. Right. Okay. Next one. Now if you take the micrometer problem. Now if you take the micrometer problem, so the same formulas what you have derived here, you are applying in this one. Just see here. Now a micrometer having a ratio of a reservoir to the limb areas is 40, was used to determine the pressure in a pipe containing the water. So pipe law, what you are having a water, right? Determine the pressure in the pipe for manometer readings. Now so question lo meeku only ఒకటే ఇచ్చాడు reading. By seeing this figure we can take the given data. So what is the S water is 1, that is specific weight of water is equal to 1, so which is standard one. So if the values are not given in the question, just assume S specific weight of water is equal to 1, specific weight of mercury is equals to 13.6. okay na? Next, atmospheric pressure. See here, the atmospheric pressure, P atmospheric pressure is equal to 101 kilopascal. Then what is the ratio it is given? The ratio is A by A. The ratio area by small area is equals to 40. Then what is the H1? Left hand side of the limb. Is the left hand side of the limb, right? This is a left hand side of that limb. This is a right hand side of the. Again, you are having some technical issues. You are having some technical problem. So morning anta baga jarigindi. I took 2 classes. Now we are having some technical issues. Don't get worried. Unmute all. Okay, okay, you are having some technical problem. Now the problem is solved. Okay, we'll switch on to the class here. Okay, now see the problem here. So whenever you are taking the values h1 is equal to 50 and h2 is equal to 80 mm, as shown from the figure. H1 is 50, h2 value is 80 mm. Now equating the pressure heads on both sides of the manometer limbs, we have what we have took from the earlier formula. This one, this one, right? This formula, because then what is it showing here? H is equals to A by A, make it as a bracket, H2 S mercury minus S water, specific weight of mercury minus specific weight of water, plus H2 specific weight of mercury minus H1 specific weight of water. Now substituting these values in this formula, 1 by 40 is equals to 0.8, H2 is equals to, convert into 80 mm into meters, 0.08 meters into 13.6 minus 1 to the bracket plus 0.018, 0.08 into 13.6 minus 0.05 into 1. Now the height of the water is 1.06 meters of water. Now the height is 1.06 meters of water. Now what is the pressure we have to calculate? When the height is given, when the pressure head you got, when the height you got, the pressure is equals to alpha into, gamma into h, then what is the gamma of water? 9.81. In some problems or books you will get W here. So about P is equals to W into H and what is చెప్పొచ్చు. And what is the weight here? Weight of water is 9.81 into 1.06, that is 10 kilopascals is a pressure what is to be determined in the pipe of for manometer reading, right? So this is a formula you have to apply whenever you got the specific weight of two liquids as well as a ratio of the limb for the manometer. Okay, now next, see the second question. Here the second question is, it is in the inclined manner. So initial గా మనకి పైప్ ఇలా ఉంటుంది యూట్యూబ్ లో. ఇప్పుడు inclined గా వచ్చినప్పుడు then you have to use the angle alpha. Okay, now see the second one. An inclined micromanometer having the ratio of reservoir to limb areas as 10 was used to determine the pressure in the pipe, so we have to find the pressure in the pipe containing the water. Determine the pressure in the pipe for manometer readings if the inclination of the manometer has 4:1. So here it has given the readings that the ratio is 4:1. The ratio is 4:1 as shown in the figure. Now from this figure, first write the given data. So what is the given data here? Specific weight of water ఇవ్వలేదు కాబట్టి we have to take one. Specific weight of mercury, so we know that it is 13.6. Then what is A by A? It is 10 ish given in the figure. Okay, na? The ratio is 10. The ratio is 10. What it is given? 10. That is 0.2. That is, then what is the length here? The length is 0.25 meter. The length of the slant tube is 0.25 meter. Then what is the H1 from the figure? H1 is 50 meters, that is 0.05 meter. Then what is the H2 here? Because you are having alpha, you are having an angle here, that is S sin alpha, that is H2 is equal to L into sin alpha. What is the L here? 0.25 into sin 14. How you are getting sin 14 here? So here the angle is 1:4. Here the angle is 1:4. So by deriving this one, we are getting sin 14 is a angle that is equal to 0.6 meter. Now equating the pressure heads on both sides, then what is the formula you have to keep here? So this is the formula you have to keep. This is the formula for angle. This is the formula for the angle. Now apply this formula at this point. H is equals to A by A, L of sine alpha S2 minus S1 plus SL sine alpha S2 minus H1 S1. Now directly substituting these values, here H is equals to A by A is equals to 10, that is equal to 1 by 10. L sine alpha is equals to 0.6 meter, that is equal to 0.06 into 13.6 minus 1 plus L sine alpha is 2 0.06 into 13.6 minus H1 is equal to 0.05, S1 is equal to 1. Now total calculating, we are getting the height is equals to 0.84 meters of water. The height of water is 0.84 meters. Now what is the pressure? The same formula. Pressure is equals to P. P is equals to W into H or gamma water into H. Therefore, 9.81 into 0.84 is equals to 8.25 kilopascals. So whatever the problems you are getting in the exam, first you have to find out H value. First you have to find out the H value, right? First you have to find out the H value. Next you have to find out the P value. So in some cases, if P is given, H you have to find out. Okay, na? Here H1 and H2. Here H1 and H2 are given in this figure only. So only the thing you have to find is the height of the water as well as the pressure in the pipe. Pressure in the pipe. So this is the formula we have to apply. You have to apply whenever you are getting inclined micrometer problems. Understood? Next concept is differential manometers. Next concept is a differential manometers. So the differential manometers are also same as that of the general manometers, but what is the difference here? You have to check the 2 points. You have to measure the 2 points between the liquids. The differential manometer is used to measure pressure difference between any 2 points. Common types of differential manometers are, the first one is 2 piezometers, second one is inverted U-tube manometer, third one is U-tube differential manometer, fourth one is a micrometer. Now already in the first class, in the initial classes, we have discussed about the single manometer in the piezometer. So here we are using 2 glass tubes. There we have chosen only 1 glass tube. Now from this figure you can see if this is a pipe, where the pressure of the fluid you have to find. Okay, now applying 2 tubes on the pipe, at some point we can see the changes. We can see the pressures of the pipes in the liquid. Now see the 2 piezometers. The arrangement consists of 2 piezometers at the 2 points between which the pressure difference is required. So you are having a container which is a pipe shape. In the container you are having the fluid. The liquid rises in both the piezometers. So whenever the piezometer is placed here, automatically the liquid is rising from the tube to the piezometer. The difference in the elevation of the liquid levels can be recorded and the pressure difference can be calculated. It has all the merits and demerits of piezometer. So whatever the merits, very simple, very old thing, adi manam mundu cheppukunnam piezometer gurinchi. So whatever the merits and demerits you are having in that single piezometer, the same thing you are having in this piezometer also. Okay, na? Now how you are seeing? So whenever you are connecting one piezometer, at a certain distance, again you are connecting the second piezometer. Then if you see the difference, automatically the water moves from the container to the piezo glass tube as shown. But you are having some changes in the pressure head because of the alignment, because of the gap you are maintaining, Then, so if you take the total height, from the center pipe of the container, this is a total height, atmospheric total height. The second one, you are having first pipe manometer IH, this one is a HB. So if you see the differences, pressure differences, automatically you can how much distance you are maintaining here. Now if you see the YouTube differential manometer, initial classes lo manam em cheptunnam, you are having only one setup, one container. Now you are having two containers, left hand side and right hand side. Now see, a differential YouTube manometer is used to measure a pressure difference between the any 2 points. Now a differential YouTube manometer is used to measure a pressure difference between any 2 points, see here, XA, XB. These are the 2 points where you have to measure. It consists of YouTube containing heavier manometric liquid, the two limbs of which are connected to the gauge. The two limbs, what are the two limbs here? Idoka limb, left hand side limb. This one is a right hand side limb. Okay, now the two limbs of which are connected to the gauge points between which the pressure difference is required. The YouTube differential manometers can also be used for gases also. So generally we are using for measuring the pressure of a fluid in a container, closed or open container. Kani YouTube differential manometer em cheptundi, these are also used for measuring the gases also. Okay na? By writing the gauge equation for the system, pressure difference can be determined. So whatever the derivation we have done for the previous manometer, the same thing also you can do by checking the gauge equation, and the pressure difference can be solved. Now if you see the figure here, we are having two containers, pressure left hand side one container and right hand side other container. Now if you see a point A in the container, the point B in the container. This one is the manometric fluid where it is SM and mercury specific weight. Here S1 is a specific weight of a liquid, S2 is a specific weight of a liquid. Now if you see the datum line X, now the height of the water from the datum line is Y1, the height of the manometric fluid to rise is Y2, right? Now the same thing if you see the two YouTube differential manometer, so you are having pressure A at one fluid 1, the pressure B at fluid 2. The black color portion is a mercury. Okay na? The height of the water from the datum line is H1. The height of the water from mercury to the second container's height is H2. Then the height of mercury is a H. Now YouTube manometer consists of a U-tube. So this is a U-tube, the two ends of which are connected to the two gauge points between which the pressure difference is to be measured. The manometric fluid contained in the U-tube is a heavier fluid, that is mercury. Mercury is a heavier fluid than water, that is its specific gravity should be greater than the liquids in the pipes, and it should be immiscible, and also the specific weight should be greater than that of the water what you are having. Okay, now next from this figure, if you see the derivation, let PA is a pressure at A of a fluid 1, PB is the pressure at the container B. Now H1 is what the H1 see here, the distance of the center A from the mercury level in the left limb. So mercury level nunchi distance of the container, distance of the center A from the mercury level of the limb is equals to H1. Then H is equals to difference of mercury level, the difference of mercury level in the U-tube known as manometric reading. So what is the H here? The change, the difference in the mercury level. Then H2 The H2 is the distance of the center B, the distance of the center B from the mercury level in the right limb. The distance of the center of B from the mercury level in the right side limb. So this is the right side limb. This is a left side limb. Okay, na? Now the distance of the center B. See here, the distance of center B from the mercury level is nothing but a H2. Next, the specific weight of a liquid in the pipe A is equal to S1. The specific weight of the mercury is equals to SW or SM. You can write S or SM also you can write. Next, the specific weight gravity of a liquid at a pipe B is equals to S2. Now, the specific weight of water generally is S. So, these are the inputs what we have seen from the figure. Next. But we know that the pressures in the left hand side and right hand side above the datum line XX are equal. So, when these two are equal, and hence the pressure heads are also equal. So, pressure heads are also equal. Then pressure head in the left limb from the figure, by seeing the figure, pressure head in the left limb is equals to PA by W plus H1 S1. PA by W plus H1 and S1. Pressure head in the right hand side, PB by W, H1 S2 plus HS. Why it is H1 S2 plus HS? Because in the right side, both you are having mercury plus water above the datum line. So it has been taken in the two things, PBW plus H2S2 plus H and S. Equating the above pressure heads, we get PA by W plus HS1, H1S1 is equals to PB by W, H2S2 plus HS. Okay, now. So after equating this one, so we are taking the common, PA minus PB by W is equals to H2S2, H2S2, HS. This one is this side వచ్చింది కాబట్టి plus ఉన్నది minus అవుతుంది, minus H1S1 meters of water. Now HA minus HB, HA change in the height, HA minus HB is equals to H2S2 plus HS1 minus H1S1 meters of water, where HA and HB are head of waters in the pipe A and B. So what are the pipes here? We are having two pipes, A and B. So this one is a pressure, this one is a pressure heads. So these are the pressure heads in the pipeline A and pipeline B. This U2 differential manometer is connected to the pipe through which the certain fluid of specific gravity as one of the following can be determined. So when you are considering the piezometer at two different points in the container, H1 is equals to H2 plus H. H2 is equals to H1 minus H. Specific weight is equals to same, equal. H is equals to S1 is equals to H2, right? Okay. So with this, we can solve the problem based on the two dimensions of the object, right? Now, the difference of pressure heads A and B, the difference of the pressure heads at A and B, HA minus HB is equals to H2S2 plus HS minus H1S1 meters of water. How it is done? This one, see here. HA minus HB is equals to H2S2 plus HS minus H1S1. The same thing, it has been written. Now that implies H1 minus H, H1 minus H, bracket lo we are having S1 plus HS minus H1S1. Okay, H1S1. That implies H1S1 minus HS1 plus HSS1 minus H2S1. So after getting derived, we are getting H1 into S1 minus H into S1 plus HS minus H1S1. Next, then what is the total HA minus HB? HA minus HB is equals to we are taking, what is the common here? We are taking h of s minus s1. We are taking h of h minus h s1, right? Both of where h is equals to manometric reading of differential manometers, and can s minus h1 meters of water, where h is equals to manometer reading, where h is equals to manometer reading of a differential manometer. The same difference in the pressure heads can be written in the terms of a liquid flowing through the pipes. The same difference in the pressure heads can be written in terms of a meters liquid flowing in the same pipe. So whenever you are applying in the meters, in terms of meters, HA minus HB is equals to H of S minus S1 by S1 meters. That implies H common this SE. So we are doing the LCM common, S by S1 minus H by S1 minus H1 meters of liquid, or you can leave at this point also. There S is equal to specific weight of mercury, S1 is equal to specific weight of liquid in the pipe. In the above equation we can write H is equals to X into SM. SM and in the S place low, SM plus S pettamu. Now SM by S0 minus 1 meters of liquid, where H is equal to pressure head, X is equals to manometric reading, SM is equal to mercury specific rate, S0 is equals to specific gravity of oil flowing through the pipe, right? So with this we can easily start the problems. Now see, in the last problem you are having one container, here you are having two containers, okay na? Now a differential manometer is connected at the 2 points A and B. So this is a differential manometer where the one end is connected to the container A, the other end is connected to the container B as shown. Now at B the air pressure is 9.81. So the air pressure is 9.81 into 10 to the power of 4 Newton per meter square. Find the absolute pressure at A. Find the absolute pressure at the point A. So what is it given here? The oil specific, okay. Air pressure at B is equals to the air pressure at B. The air pressure is 9.81. So at air pressure B, PB is equals to 9.81 meters per 9.81 into 10 to the power of 4 Newton per meter square at B. This one 9.81 into meters per meter square. Now the specific weight of the gravity, the specific gravity of mercury is equals to 13.6, as already know. The specific weight of oil is equals to 0.9, which is to be mentioned in the problem. Then what is the H1? 20, H2 60, H is equals to 10. Now from this figure, considering the pressure heads above the datum line of XX, we have the pressure head on the left hand limb, the pressure head on the right hand limb. So if you are just applying those values here, if you are just applying those values at this point, we can say the pressure head on the left limb is equals to PA by W plus 0.9 into 220 by 100 plus 13.6. So what is the formula for this one? The above formula is said as PA by W, this one. PA by W, this one, PA by W, H1, S1 plus HS. The same thing you are applying for this problem. Now PA by W plus 0.9 into 20 by 100 plus 13.6 into 10 by 100. Pressure head on the right hand limb is equals to PB by W plus 60 by 100 into 1. 60 by 100 into 1. So what is 20 by 100? This one, see, it is in the centimeters. 20 centimeters ఉంది కాబట్టి meters లో కన్వర్ట్ చేయడానికి వీళ్ళు ఇక్కడ వాల్యూ వేశారు. లేదంటే మీరు డైరెక్ట్ గా ప్లస్ 0.9 స్పెసిఫిక్ వెయిట్ ఇంటూ 0.02 ప్లస్ 13.6 ఇంటూ 1 ఇంటూ ఈ 10 అంటే 0.0 అని పెట్టుకున్నా సరిపోతుంది. Now specific rate of water, okay, it is normally 1. Now while equating the above pressure heads we get, so దీన్ని so మీరు ఈక్వేట్ చేయండి. After getting equation you will get directly PA by W is equals to 9.84 into 10 to the power of 4 divided by 9810 plus 0.6 minus 1.54 minus 1.54. Now the weight of water is already known, 81810 Newton per meter cube. Then after substituting these values you are getting 9.06 meters PA. Now PA is equals to 9.06 into specific weight of the particular liquid, and PA is equals to 9.06 into W. What is W? 9810. Then 8. So substituting in these values, we are getting 88.2 kilopascal. So that is the overall length of the overall pressure of the atmospheric pressure, PA. So the PA where you are having the value. So what is the question given? Find the absolute pressure at PA. Find the absolute pressure at A. So we have got the pressure at A. I think hope you are understood now. So 4 participants are there in this class. Okay. Now to see the second one, a differential manometer is connected. A differential manometer is connected at 2 points. The same question what you are having in the last thing. The same 2 points are there. The 2 liquid containers are there, which are in the left hand side and the right hand side of U-tube manometer. U-tube manometer. Here, the U-tube left hand side is connected with one container, right hand side is connected with the other container. A differential manometer is connected 2 points at A and B of the 2 pipes. A and B of the 2 pipes as shown in the figure 1.26. The pipe A contains a liquid. This pipe A contains a liquid. The pipe A contains a liquid of specific gravity 1.6. You are having 1.6 under pressure of 110 kilonewton per meter square. The pipe B contains oil. So the pipe B contains an oil. It contains an oil specific gravity 0.8. Specific gravity is 0.8 under a pressure of 200 kilonewton per meter square. Find the difference in the mercury level in the differential manometer. So E black color, the mercury is in the black color. We have to find the difference in the mercury level, height and matter, right? You have to find the height. Now by seeing this figure, we can write the given data. What is the given data? The specific gravity of a liquid A is equals to 1.6 S1. Next, the specific gravity of a liquid B S2 is equals to 0.8. Next, the pressure at A. The pressure at A, PA is equals to the pressure at A. What is the pressure at A? The pressure at A is equals to 110 kilonewton per meter square. Next, the pressure at B is equals to 200 kilonewton per meter square. Then what do you have to find? The heights in the levels, right, in the levels. Now if you take the pressure head at A దగ్గర if you take the pressure head, H of A, height A at A is equals to P by PA by W is equals to, what is PA? 110 by 9.81, that is equal to 11.21 meters of water. 11.21 meters of water. Now next, pressure at B. The pressure at B. If you take the pressure at B, PB is equals to 200 kilonewton per meter square. Now the pressure head at B is equals to HB, PB by W, that is equal to 200 divided by 9.81, that is equal to 20.38. Now the pressure head above the datum line XX in the left limb. So ikkada XX lo left hand side lo ent undi. So you have to calculate this one, right? Now at A is equals to HA plus 3.6 into 1.6 plus H into 13.6 meters of water. Now the pressure head above the datum line in the right hand limb. In the last case it is in the left hand limb, it is in the right hand limb. Now HB, that is equal to HB plus H plus 1 into 0.8 meters of water. Now equating this both the left hand side and right hand side, you are getting HA